If someone pulls the alarm because they think they're funny, you can go that way, and you can go that way. But that's all you're going to hear from me, which is wonderful. I'm going to hand it over to James. James is going to be talking about 3D printing. Over to you.
All right. Hello, everybody. I think I know most of everybody here. Thanks, Gord. And Negan was, where'd she go? Oh, there she is. She's been putting up for me for the last couple weeks, talking about what should we do this or should we do this or where do I put it and all that stuff. And I think Melanie, who's hiding in the back, said it best when I was talking to her earlier in the week, and she says, I'm coming. I said, why? And she goes, I don't know. I can't understand the idea of a printer making things other than a piece of paper. And I was like, oh, that actually makes sense, because I frankly didn't either at one point in time. So anyway, yeah, my name is James Layton. I don't have a ton of slides. I'm not going to lie to you. I have a lot of things I'd like to show on screen that are programs and pictures and stuff like that that will actually aid to a lot of the conversation. But I do want it to be a conversation, because 3D printing, or if you know me, I can get kind of lost into a conversation. So the slides are to keep me on task, but at the same time, feel free to ask a question at any point in time. If it's coming up on a slide, I'll have you hang tight. I also threw out a bunch of trinkets when I started into 3D printing. You just generally try to find stuff to print for the sake of printing. I'm not going to lie about it. So I've got all sorts of, like, my daughter's here tonight and she'll attest to, I'll find something and be like, I can do better. So I make a new one of those and my wife will go, what? Okay. And away it goes. Well, she's come around to, hey, could you make this? Or, hey, could you make this? So I say she's allowing me to do this now. I'm not sure that's true, but anyway. But so please jump in whenever. I'd appreciate it. Go from there. So introduction, who the heck is this guy? Like I said, I'm James Layton. I grew up on a farm just outside of Beanfate. I'm not a farmer. I don't look like a farmer. I do not want to farm. This is not a surprise to anybody. Ran a retail store in Estevan for a little over 8 years. Moved from there to Estevan Web Printing, where I was IT manager and brought on a multi-million-dollar print plant in Estevan. Did that for about 5 years. 5 years after I moved into their general manager position, and then moved, and I'm now with the city of Estevan as the IT manager. So back to IT full-time. And long story short, I am a self-proclaimed nerd. If anybody knows me, you know that that's through and through it. Married to my wonderful wife, 15 years, 2 kids, 1 here, and my dog, Chip. So if I didn't say I was a nerd before, my dog's named Chip. So how did I get here? That's an interesting one. My wife sent me a picture once. I've held on to this picture for about 10 years now. And it's this. So she sent me this and said, look, it's you. Generally speaking, when I kind of get into something, it's all or nothing. Right off the deep end, that's generally what I do. She's not wrong. So essentially where we went with this is, how did I get going into 3D printing? I got into a number of years ago, LED lighting. This is stuff you see on people's houses, inside bedrooms. I mean, it's become a kind of a thing you grab at Walmart. It's become very commercialized, and that's great. But in my case, I was doing the LED lighting, the housing that was in it. So this is just a general housing box, and it was way too large for my purposes, but this was me playing with LED lighting. So in that, I got into, well, these microcontrollers that run these LED lights. As you can see, they're just a labyrinth of could be wires, and these are breadboards that you just plug in wires. And this is kind of the stage of where you start playing with this stuff. And then when it's finally finished, you generally need to solder it all together, shorten it up, make some wires, etc. And I thought, I need to do something better than just throwing this in a little box. And of course, you go to Walmart or Canadian Tire and you find a little box, and it was too big, too small, didn't quite work, wasn't waterproof enough, etc. So I mentioned to my friend, I got a friend who, the same guy actually got me into the LED lighting. we were talking one day and I said, I got to find a better housing for this. I would like to mount it outside the house, et cetera, et cetera. And he's just like, well, you should get a 3D printer. Okay, what's that? Keep talking. So he's like, oh yeah, I bought this 3D printer and I can't really figure it out, but maybe you should look into it. So Jeff, my wife and my kids have never met Jeff, but he's a well-known name around the house before. It's Jeff's fault. Everything related to 3D printing is Jeff's fault. So I literally took a screenshot of the slide and sent it to him, and he said, yeah, I'm fine with that. So we went from, okay, how did this start to how's it going now? So this is kind of a setup this was a little earlier of a picture of a setup in my basement. I went from one printer to very quickly a second printer, filament dryers. We'll get into that a little bit later because filament attracts water, causes other issues. And this is now a temperature controlled room, humidity controlled room. Yeah, I kind of got a little out of there. But then, of course, when you're printing something, it's in this color. Well, then you need to buy a bunch of colors. So I've got a lot of colors in the rainbow. And I brought some here. And this is just kind of a quick example, but they actually make filament in all sorts of colors, but they actually make some in multicolor, which allows the color to change throughout the print. It's something I grabbed for a project for my wife, actually, and it turns out to be a very interesting scenario. So, and they make clear, glow in the dark, very bright colors, et cetera, et cetera. So that's just an example. We'll get into some of that in a little bit. So the way it started was a friend of mine, Brian Wright, vice principal up in the comp school. I folded him up and I said, I think we should get a 3D printer. I don't know, my wife's not really thrilled about that idea. And I said, well, mine either, but how about we go half? And our wives approved, and away we go. So after I got my printer, this little one here that's not actually doing something at the moment, after I got it, it was about 3-4 weeks later, I kind of sat down with Brian and kind of broke the news to him that I'm not willing to share anymore. And he didn't pay me for his half anyway, so it worked out pretty good. So now he has one as well, and I spend a lot of time in his garage mucking with things. So anyway, that's kind of how it's progressed, and it's one of those, I think we mentioned a little bit earlier, it's no different than any other hobby. You kind of get into it, and it's how far you want to get into it, and there's a lot of options and a lot of brands and techniques and stuff like that. So what I want to do is I want to talk about what is it? What is 3D printing? And in an overview scenario, what we want to, it can break it down into a couple different stages. And the first one is digital design. You have to start with something or have something to print. And again, we'll worry about the print stuff in here in a minute. But essentially, whether you create it or you get it, and there is tons of resources online to get stuff. And that's a lot of what you see here on this table is stuff that I found. And there is a huge community of people that it's not a matter of you don't want to design it, but why recreate the wheel if it's already exists? So there's a lot of stuff that's out there. It's exactly what you need. You can size it up, size it down, et cetera, et cetera. So you generally start with that, something like that. You create it. We'll get to that in a second. Or another getting to be a little more popular is a 3D scan. You actually take a 3D scanner and you actually scan it. So I'll get to that. Just want to go through the overview and then I'll nail some of them down individually. Next, we slice it. That's the word for actually turning it, this object, whatever it is, circle, cube, whatever, into a layered, structured instruction that the printer can handle. So these printers, and we'll get all 3D printers generally work a layer at a time, painstaking layer at a time. So generally, just like when you print to an actual computer printer, like paper comes out, it gets converted into something that the printer can understand. It doesn't know what a letter T is or anything like that. Likewise, a 3D printer doesn't know what a boat is or a block or a circle or anything like that. It only cares about where am I putting filament, plastic, onto where in this space. Makes noise. So we have to kind of convert it, and slicing is a huge part of that, and we'll get into that. It's a really powerful program that allows you to do a lot of manipulation to some files. The second last thing is we go to print. Once that is actually converted into a machine code that it understands, we need to melt some plastic and get this going. So layer by layer, you're actually putting a very, very thin, incredibly thin, like a thin piece of paper essentially, over top, over top, over top. And then of course there's post-processing, which sometimes there's a lot, sometimes there's not a lot, depending on what you're trying to do. I don't do a whole lot of things at post-processing. I don't have a surgeon's hand to paint or anything like that, but we'll jump into that. So we'll start with the first point, and that's the digital design. So we generally start with a computer-aided design, and there's a lot of options out there. And the nice part about that is when people hear CAD, they go, whew, this is going to be expensive. This hasn't cost me a thing up to this point, and I didn't steal anything, I promise. So this is where I'm going to digress a little pretty quickly here and go right into these programs. So essentially, with the CAD systems, I'm going to talk about 3 different ones. The first one is called Fusion 360, and it's made by a company called AutoCAD. You've probably heard of them. They make the Fusion Fusion is essentially a AutoCAD clone in a sense, but it's designed to be very, I'm going to say easy-ish. Most like anything, there are courses out there. I've actually enrolled in a couple of courses, gone through them, but essentially, and my mouse is going to be, there it is. But essentially you can actually, you get an item. I'm going to quickly make something. And a CAD, let's just say this is a box of some sort. This is just a 3D rendering of an item. And it can be a certain height. You can actually edit it. You can do a lot of stuff with it. You can start from a blank slate, et cetera, et cetera. This is a beast of a program. It can be very maddening some days, but I think that's the definition of CAD in the second definition in the dictionary. But more importantly, this is free for personal use, for non-commercial use. So I can have up to 10 files in this program editable at any given time. Meaning if I'm not working on something, I just mark it as read-only and you still are working within the 10. I've never ran into an issue. It's a great program, tons of advice online on how to function with this. And as long as you're not using it for commercial purposes, it doesn't cost anything. So it's a really great program. I'll exit out of that if I can find my mouse. 2 different screens. The other one that's really common and seems to be really taking shape right now is one called Onshape. It is a web-based version, if I can say, of something like Fusion 360. I understand it is quite a learning curve to get into it. It's a very different mentality to use, but it is completely free for non-commercial use. And of course, they want you to pay for extras and bells and whistles and maybe storage or something like that. But from what I understand, you don't need to do that. Past that, the other one I wanted to talk about is something called Tinkercad. Some of you may have ever heard of that. I know my daughter has, because this is a big thing in education. However, I actually think this is a really good starting point. AutoCAD also makes Tinkercad. It is full available, or it's completely online. Just going to pull it up here and make sure I'm logged in to show you what the heck I'm trying to show you. And then I hit the wrong button. But essentially, Tinkercad is a complete online system, just like Onshape. But this is designed to be, I'm going to say basic, but I've seen some people do some pretty interesting stuff with this. And the idea behind it is that you can actually create a 3D, if everybody remembers Microsoft Paint, it's a pretty easy program to just sit and play with. So, I mean, you can literally just go in here, plunk a box down, make it this big. Hey, I want to throw a hole in here. I can just grab that properly, throw it in here. And I'm being very quick and just kind of a quick example. I didn't make that hole big enough. Can do also, oh, there, the hole is there. So you can actually create a lot of different things in this program. In the education side of things, they play with this quite a bit. This is a great starting point. If you're trying to make something really small and tiny in your house or something like that, you could do it in Fusion, but you'd probably whip it up in Tinkercad in about 10 minutes, maybe 15 if you swear at it enough a little bit here and there. But for the most part, I can actually export this and move on to the next step, which is slicing. And I'm actually going to do that just as an example right now, so we have a live example. So right here, they're going to try to sell you right into the Fusion program. But like I said, you could take it into Fusion and do some more work if Tinkercad didn't do this. I'm going to actually drop it right out to an STL, which is what a slicer uses. I'll get to that in a second. Don't have to worry about it. It's just a file. So if I drop that in here, they have this really neat idea that you don't have to name anything, so they just give it weird names. This is Stunning Sango. I don't know. They do this with all of their items, so that's now sitting here waiting for me to be able to slice. Not to worry about it. That's kind of the basics to create an item. So you can go into the CAD world, and again, this is not going to be right into the CAD world. This is not meant to be that type of class, which I probably am not a good person to teach that anyway. It's a lot longer. But at the same time, just as a quick example to get something that we could go to print with. So that said, I talked about if we go back to the slides, I had mentioned that we were going to do, there's two different ways. One being you can create an object or find an object online. The other is the 3D scan. I'm going to just leave that on the screen for a second. Pull that back. So a 3D scan, this is turning into quite a scenario. And the best way for me to do this is to throw it up here in a video. So companies create these 3D scanners, and they're exactly that. You can see here. They're handheld scanners. They can be designed to be portable, plugged directly into your phone. This may be on my Christmas list. Didn't show up last year. We'll see what happens this year. But the idea is exactly this. You can scan these items. I'm going to try to, there you go. And the software on the other end is essentially recreating that in space and time. So this is a really quick video, but essentially you can, and of course there's the 3D aspects of scanning something in for game development. And for today, we're going to quick fly past that. This is a good example of it. This guy had actually created it looks like a bumper on a vehicle, and essentially you're doing opposite. You're not actually scanning something, you're scanning the void of it and then creating the part to go into it. So reverse engineering that for the part to plop it. Yeah, good job. But as you can see here, this is really real world application of what 3D printing can do. Not sure what you're going to do with a birthday cake, but maybe if you wanted a copy of it or something like that. But as you can see here, this is something that you can scan. And when you turn that into an item, that item is now a printable item or something you can, much like you can take a photograph and use Photoshop and kind of tweak it and make it better, etc. These things are incredibly accurate, or they're getting to be very, very accurate. And then you can do a lot of different things with it. So this is kind of an up and coming growing area. Love how they blurred out like we don't know what brand of shoe that was. But a lot of people are scanning this stuff in, and yes, I'm sure they're using it for game design or stuff like that, but they're taking it and tweaking it instead of creating it from scratch. I'm not sure what that's about. Nonetheless, there you go, making your own insoles. There you go. Could be. I'm not sure I'm qualified to make those, but nonetheless. So that I figured the video was probably the easiest way to describe what this 3D scanner is. Like I said, I don't have one. I haven't had a whole lot of list of things that I need to create one with. So for now, it's just on my want list. So like I said, that's generally the quickest two ways to get that in. I'm going to quickly pull up. Oh, right. I'm already in this. Did I spell that right? I did. There are websites, a number of them. This is the company that makes these two printers. They've got a various number of departments, but there's a lot of these companies that create these web sites that people can upload all of their designs if they so choose to share them or anything else. And there is, you imagine it, it's probably on here, including all sorts of designs in, I'll get to some of what people do with game design, figurines and stuff like that. Not something that I've dabbled in a whole lot, but I'll get to it. But I mean, a website like this will generally have models that, I'll just click on this, get a little bit better of models, you know, wall hooks and desk drawers and you name it. And these are all free. These are all free. And these websites have so much stuff in here. So there's a good starting point, especially if you're not into the design side of things. You can get a lot of stuff. Again, pretty much everything on this table comes from these websites. And there are some that you can pay money for and such, but there is gobs and gobs and gobs of these type of websites out here. So every once in a while, I'm looking for, I should try to print something like this, and I'll have to make it. And then you sit down, you type it in. 100 people have already made this. So pick one that works for you. Maybe make it a little bit bigger, maybe a little bit smaller. I've actually grabbed some things in here, dropped them into Tinkercad because I needed a hole somewhere. I'll just drop a hole in there and export it, and away I go. So this doesn't have to be hard. I mean, I'd say for probably the first 3-4 months that I was really into this, I didn't design anything. But then you kind of got to a point where you're like, all right, I understand this enough. Let's take it one step further. So this was kind of, I moved into the design side of things. So don't let design be the barrier of entry. So, all right, moving on from there. So we talked about the CAD design and the 3D scan of a surface item. The next step in this process is slicing it. So slicing is the word that they use to take that object and again, turn it into that, again, from that CAD or wherever you got it online, and turn it into that instruction set for the printer. This is probably one of my favorite areas because it gets super nerdy and you can actually see the potential before it goes to the printer. So this is kind of the print preview. If you were to print, Jeff.
Quick question. So when you're downloading it from that site, are they come as CAD files or do they come as the slice files?
They actually come, so they're called STL files, which is essentially the ready to be rendered in the slicer program. And there's probably a good dozen of slicer programs. They do things a little bit differently. I use the program that is made by the company that works with these printers, but that's just what I started with, and they're one of the best. That's my opinion. I shouldn't have said that, but I'll show you why. There's a lot of pretty cool stuff they do. So that Tinkercad file, for example, I exported that as an STL file, ready to go. I could export it as Fusion file, but at the end of the day, even when I'm in Fusion, and I'll show you that at a later point here, when I'm in Fusion, that's a CAD file. But when I want to print it, I actually export it as an STL file, and it's ready to go into this next stage. So when you slice it, there's options. There's always options. This is a never-ending options game when it comes to 3D printing. So there's really 3 things. Infill, and that is, what the heck's inside of these? So for example, I'm just going to grab a dinosaur. Printed this one. So this is when James is trying to figure out what purple actually looks like. I need to print something. So I printed it. Sits on Aaron's desk usually. So I don't keep these myself. So inside of these is not solid plastic. They're not hollow either. I'll get to that in a second. So infill has a lot to do with the structural integrity of how this is actually created. Yep. And the other next step is you can actually pause the printing, and people pause that for insertion of magnets. So for example, this printer, which should finish while we're here today, by the way, that was the plan anyway. This one's not a print that will actually need something inserted in it. But there are times where you may want to put a magnet in, or other people use, and I haven't done magnets or with filling it with something, but there are certain people that will fill it with like an epoxy or a resin before it's finished. So halfway up, it's open, want to fill it up with something, and then tell the printer to continue, and then it just kind of finishes it up, puts the lid on it essentially. And then supports, because gravity sucks. These things can only print on top of each other. It cannot print in thin air. Gravity will not make that work. So I'm going to show you how all this works as well. But those are generally where we're going to jump into when we slice it. Now, I'm going to actually open up the program that I use is called Prusa Slicer. These are Prusa machines. That's the company that that makes these machines. And like I said, they have a printer division, a software division, a R&D department. They're a big company. Regardless, and I know others that have heard, we'll get into maybe some other names of some printers. These are definitely not the only ones. There's a million of them. But essentially, this is what we call a slicer. This is essentially, it gives you kind of a preview of the sheet that's sitting right on your bed. So on a printer, we actually have a magnetic sheet that is heated up. So this heats it up to about, in my case, I'm shooting at about 60 degrees. And the actual plastic is extruded out of the nozzle at about 215 degrees. That's the type of plastic I'm using. And it's a very delicate balance of it being extruded and cooled so that it turns into a solid plastic. So what you're seeing here is the actual bed. And in this case, if I quickly open up that file that I made in Tinkercad, Stunning Sango, that was the name of it, I believe. There we are. That is the masterpiece that I have created today. I'm so sorry for all of you. I've once again lost my mouse. There it is. So this is kind of a quick preview of this is what the bed looks like. And this is just the object. We've done nothing to it. It has not been converted into anything. This is just the item. I'm actually going to change this really quickly to the smaller printer. And there we are. So at this point, we can actually say, all right, let's slice it. Now, what the heck does that mean? So it actually goes through and computes a bunch of stuff. I'm going to hide that so it's a little bit smaller. And there is our item. And you're going, well, it looks the same to me. Nothing's changed. But if you actually take it, this is 264 layers of plastic to make this. And this is only, how tall was this thing? Helps if I click on it. 2.7 inches, 1.5 inches tall, you can see the size, the dimensions. It's not very big. This stuff takes some patience, and that was not something I did well with when I started this process. Regardless, if we go back to the actual item, 264 layers, I can actually pull back the layers, and you can see here, let me zoom in a little bit easier here. You can actually see here, this is the process of what it's actually going to do inside individual layers. So this is whoa, that's what's inside. And so if we actually look at this, and I'm just going to hold a button down, this is a preview of what the printer actually does. Painstakingly, I mean, not that slow, definitely, it goes a lot faster, but this is what you can drill down and see, why is it doing that? And this is where you can find out, oh wait, this can't print over nothing. Gravity is going to screw us over here. And I'll get to what that looks like here as well. But this program is this is that nerdiness of geometry that's being told where that head is supposed to go, at what speed, how fast that plastic is being fed into that hot iron. It's essentially like a glue gun, let's be honest, just pushing that stuff through. So that's an example of this. I'll change out of that. If we go back to So one of the first items I mentioned was infill. So you can see here all of those kind of jagged lines, and those lines are what we call the infill. And it's never this easy. You'll see those lines change directions. Let me go down here. You can see how this is one of many types of infill. Let me just pull this quickly. Infill, there are different, and I know there's probably a lot of people smarter than me that know about structural integrity. Kelly's one of them for sure. But infill has a lot to do with, number one, if you're going to put things like resin or anything like that, different infill provides economy for how much actual plastic is going to be inside it. Again, if you made this actually solid, you're actually going to cause other issues because there's no room for that plastic to move if it's not calibrated properly. So you're never supposed to run at 100% infill or you'll have other issues. But you can see here just some examples of different types of infill. And there's problems that go with this. For example, I'll move down to one here. So something like this, it's actually a problem because the head of the printer will actually cross over a spot that's already got ink, or not ink, plastic. So you'll actually cause other issues where the print head is actually kind of smashing into, on a very, very small scale, where existing plastic is already. So there's pros and cons to a lot of this stuff. And there's got all sorts of reasons why, and there's people that will say, I use this one and I use this one, and it doesn't really matter too much. How you feel about it, generally, you're looking for the reasons for that. So you'll pick some that will hold water, the resin and epoxy better, and things like that. I printed off some round balls for, of all things, a potato gun. That's a whole nother story. My brother conveniently tells me after they sit in a dugout for about a week, they take on water and they're about 3 pounds each. So they're not waterproof, but we'll get into some of that stuff as well. Fun stuff there. So if we go back to this, so that's the infill. That's just something that you need to be aware of to understand. If you ever to get into this stuff, you start reading it, you're going to go, oh, okay, there's generic ones, and then there's other ones that you need for specific purposes. The next one is that I mentioned was pauses to insert magnets, infill, epoxy. Yes?
If you change your infill there about 15%, does it show up live there on the other side?
Yeah, I can. So yeah, infill, this is generally speaking, infill's generally 15 to 25%. You go 50% and it's not a lot of, I don't see many models call for much more than 30%, but you could. So for example, if I chose say 70%, and again, I have to reslice it, I have to tell it, recalculate all that stuff. And if I was to pull that back down, you'll see the amount of ink, I keep saying ink, the amount of plastic that you're using. So again, that you've told it what to do, but we're at 70%. That's a lot. Oh yeah, yeah. So we'll get to some timing here in a minute because there's a few this is a fun, hope you got all your notes, because if you start going down this rabbit hole, there's a lot of different things. But just to give you an example, if I was to print this at say 20%, I'll just quickly do let me zoom out, it doesn't matter. I can print this in 3 hours and 22 minutes. All right. And it's going to cost me a whole $1. So printing can be relatively inexpensive plastic-wise. You can print stuff, and this is based off of a calculation I've put in there that says a roll of filament is X number of dollars. And just for the record, a roll of filament is roughly $25, and that's a kilogram. So you can feed that in here, and it'll give you a rough estimate, but there's waste, and well, if you screw it up 3 times, it's a learning process, is all I'm saying. And I'm not going to lie about it. You're not going to get a printer and not have to work about calibrating it. It's a fun and rewarding experience, but it is not like plugging in your printer that you got at Walmart and hitting print and paper comes out. I truly, truly mean that. So, for example, you had asked about that. That was 3 hours and 22 minutes. If I changed that by itself to 50%, told it to reslice that again, and we've finished that, and now we're at 7 hours and 20 minutes. So drastic change. And again, we'll get to more things that can go into that timing scenario. Alistair?
You had mentioned that there's a bit of waste with development. Is it possible to melt
Oh,
that
you're going to
down?
ask me that question. In Canada, there is not a way of recycling it. So a lot of people have, so it's a fair question and one that comes up constantly everywhere you look when this stuff comes up, or in forums and stuff like that. A lot of people hold on to it. So they got a box of it and they just hold on to all their stuff. And there are some countries, North America's not generally one of them that I've found any really, but you can actually ship it to them. Because there's some chemicals in it, and I'll get to the chemicals here in a second, there's some properties that don't exactly, you can't just throw it in the microwave and it'll come back out as a pool of cheese whiz and we can do something with it again. But it's a fair question. There is some waste. Yeah, I'm not going to debate that. I wish there was something. Some people have chipped it down and then stuck it in little silicone molds and put it in their oven, and it comes out as a butterfly or whatever, and they're like, oh, cool, I've got a butter. I don't know of anybody that's doing anything more than that other than keeping in a box waiting for that it's going to happen. So I have a box of mistakes, extras. This is one of those things where you go to print something and you're like, this is exactly what I need. It comes out and you're going, oh, I thought it was larger. So get yourself a pair of calipers, a nice ruler, something, and do a little bit more homework. I think they say measure twice, cut once. It's really the same thing. So timing is definitely going to increase because of that. So, all right. So I had mentioned that the next step was pauses. There's ways to go in here and say pause at this layer, and maybe you've got spots for. I don't think I've got one. Yeah, so I've got an item here. I'll get to that in a second, where there's these holes on the bottom of this, and that's for inserting of little magnets so that they can sit on top of each other and magnet. I don't use them. They just, the print comes with them like that. So you can pause for those type of insertions. Obviously, this is the base layer, so you wouldn't have to pause for it. You'd put them in almost immediately, or after the fact, you'd glue them in. But that's an option. Again, I've not had a lot to do with any of that stuff, but it's definitely an option I want to make sure people are aware of. The last thing that's really important when it comes to slicing is supports. Again, you cannot print over thin air. Gravity will kick you in the butt. I'm going to close this item. That's not the right button. I'll try that again. So I've got an example of a device or an item. All right. So one of the things Gord is involved with is printing of a robot. Work in progress, safe to say. But this is a file that was supplied. I've not created this. It's not mine. I cannot take credit for it. But this is an example of a device. I believe this is the head of the robot. The screen goes in there or something like that. We haven't gotten this far. But as you can see, printing over top of thin air could be a little bit of a problem here. So doing nothing with this, if I was to actually say, go ahead and slice this, this program is going to be very unhappy with me and telling me that we've got stability issues. It's barely touching the plate. I don't know how, it's a bit of a problem there. Again, I'll get rid of that legend. So you can see here, and you can actually take a look, everything that's blue is going to be a bit of a problem. On top of that, it's also saying that there's low bed adhesion. Well, it's safe to say there's not much touch in the bed. So the way we get around this is we actually do supports. And the supports are essentially exactly that. You think of supports being like 2x4s, or when you build things up, even if you have to take them away at a later time. So the way, and this has been a semi-new scenario for this type of printing. Before, if it wasn't touching the bed, it was going to be a problem, or you wasted a lot of plastic, and then you ended up cutting it away and stuff like that. We can actually do supports, and the supports look a little bit like this, and it's ugly. Let me tell you that. So there's the supports. So this is an example of, we're going to put in a whole bunch of plastic of supports to make sure that you're not actually printing this in midair. You're actually printing it on top of other plastic. The nice part about this is these supports are very, very dense, and they easily snap off. However, it's incredibly wasteful, and there's a whole lot of plastic still in there. In recent years, I shouldn't even say years, I would say in the last year and a half, they've developed a new support system called organic supports. I'm going to quickly flip that on. And the idea behind it is, same way we have different infill, those lines inside, we can actually do something called organic supports. And the idea behind it is, well, you'll see here in a second, a whole lot less material with the same process. And here we are with organic supports. So still plastic, but supporting where it needs to without a whole lot of plastic. And this has been a huge game changer for this type of 3D printing, specifically because these tree supports or organic supports break off very easily. You can get in there with a pair of pliers and get really close and snip them off in chunks instead of this whole block of plastic. And they've been a real big game changer. So generally you need to be aware of that. And this is all being done post-process. So you've already created that object or found it online, and a lot of these places will say, put in support where you feel necessary. People say, my printer can do this. 8 hours later, ooh, my printer can't do this. So it's generally easier to put those type of supports in, and you can actually put your own in. You can actually go in there with an eraser and say, I don't want them here, I want them here, etc. If you know what you want, etc.
With the app showing the cost for the amount of filament, how much of a difference do the organic supports make for it?
Not a whole ton, depending on the. I actually tried to do that math before this presentation because sometimes I think this is going to use less filament, and it depends really on what you're printing, because again, those supports are very dense. If we actually take a look inside of those supports, again by pulling that back, you can see they're actually hollow tubes. So there's not a whole lot of plastic in them. It's just a matter of they're a lot easier to remove, and depending on what you're printing, speed, and sometimes filament. I have seen where you changed it to organic supports and it's taken 20 minutes longer to print. Well, why? I assume it's a matter of the head moving around more as opposed to just printing beside each other the whole time. And for the most part, we choose to go organic support or tree supports because they're easier to remove, they make a nicer finish, etc. So I've actually printed an item, was actually part of the robot, where it was so close to the bed in certain spots. I ended up doing another modification where I raised and printed the whole thing about 1 inch off the ground, off of the plate, just because those tree supports allowed it to be suspended in the air but easily to break off. So a lot of different things to think about in here, but a lot of play. It's been, these organic supports have been a huge, when I switched to them, it was, the prints came off and you just snapped them off and there was the item that you had. So it was a really big difference for me.
But how the model's defined, like if you were to tilt it, like you say, does that affect the amount of supports? Or is like typically when you're getting these, that's the ideal angle for printing?
Yeah, no, that's a fair question. So if I actually go back to the actual model without anything, I'm allowed to, again, this program is so powerful. I can cut this item in pieces. I can actually cut them and have the program automatically put in dovetails so that they fit together at a later time to glue. But to answer your question, I can choose, I want to print it on this face. Like I can go in here and actually choose, I want a different plane to be on the bottom. I could flip it onto its side. I could You can do a lot of manipulation to figure out what you think is going to be the best for how it is made. And I'll get to that in a little bit about how that structure on top of each other works, sometimes in your favor, sometimes not. Does that answer your question a little bit?
Yeah, it does.
Okay.
I'll let you.
Okay, no, let me know if it doesn't. But yeah, you can do a lot of manipulation here. Every once in a while, you're going to run into an object that somebody has provided to you that's even too big for your print bed. You physically can't print it. You can actually slice this, which is a play on words, I understand, but slicing it in half and allow you to print halves of it, connect them together, glue them together, etc. And that's kind of where that finishing spot I mentioned, where sanding and painting and things that I don't do personally, but nonetheless, it's definitely an option. Yeah, so that supports being the last thing. So exit out of this. Need to make my mouse cursor a different color so it's easier to see. So going from there, we talked about infill, pauses, and supports. Next up, print. Fire it up and get printing. Yeah, it's not that easy. Sorry, I don't mean to tease you there. But first, we need to talk about the types of printers. There are really 3 types of printers. SLA, stereolithography. The words are going to be fun here in a bit. SLA is it has been a increasingly popular type of printer. These are FDMs. I'll just get to that right off the beginning. But the problem with them is they're extremely messy in the sense that they're actually a vat of chemical, and I'll show you a video of it here in a second, but it uses UV light essentially upside down to this, and it actually dips it where the UV light will actually cure the liquid one layer at a time, dips, one layer at a time, dips upside down, kind of the opposite version of this. SLA printers generally have been incredibly more finite detail. However, these printers have, with the supports was a big thing. Those organic supports really allowed these printers to come a long way. They're incredibly messy, but they are the cat's asses from what I understand.
To make that a little more easier to understand, SLA is part of what they call it? It's resin printing.
Resin, that's correct. Yeah. So that's the chemical that it's using. And then there's a curing process and stuff like that. So definitely messy. You generally have to vent it, I understand. Again, I've never done it. I've read about this. It's not something I'm putting in my basement at the moment. I think you even have to wear a mask, like the odors, I understand. It's pretty, yeah, it doesn't sound fun. I'm sorry. Yeah, this is way easier. Everybody's gonna be fine here today. So I'm gonna cut away from that really quickly. That SLA, like I said, is the upside down version of what you're seeing here. The other one was called FDM printing, fused deposition. That doesn't sound right. Regardless, I've got a couple of videos of how that works. So here is, again, I just grabbed this one off the internet, again, from 2017. This is a definitely older printer. This is a time lapse, essentially, of what is created. So you can see there, what you're seeing here, building, there's the actual speed. So luckily, we're speeding that up. It's definitely building that one layer at a time, plastic on top of plastic. I already discussed this. And in this case, this guy actually built it in 2 different pieces, if I'm not mistaken. His head wasn't attached. I'm not sure why he did that or if there was a reason for it. Maybe supports, like he almost stopped here and then did his head. Must have inserted it. Anyway, it doesn't matter. Regardless, an SLA printing, a printer, works in the sense of, nope, that's the wrong video, sorry. There it is. So again, this is an Eiffel Tower. Again, upside down. So you can see here, this is being dipped in liquid over and over, and this is definitely sped up. And inside of there's from what I understand, a UV laser that is essentially curing that resin and turning it into this plastic or a cured model. And that's that. Again, I said there's chemical, there's lots to go wrong with it, I understand, but it has been something in the past that has been detail-wise hands down better than an FDM printer. And this world has gotten quite a bit, the FDM printers have gotten much, much better. Go back to that, yeah, FDM printers. So what are we actually printing? Plastic is not just plastic. I laughed because somebody had said, I found these rolls at Canadian Tire. They were in the weed whacker section. I can just stick that in my printer. And it's like, it may look like that, but somebody actually posted recently and said, there's a whole bunch of chemicals and oily, and it made a whole bunch of smoke on my printer. Probably not a great idea. But for the most part, there's a couple different things that we have to think about here. The types of material that we're going to print and why are they different and why do we care? So there's going to be some words here that I'm not going to say because I feel like a doctor and I will not be very good at them. The most common are the top two here, and that is PLA, polylactic acid, and I put in brackets plus. That's the most word I'm going to say here. So there's a plus. So they've actually created two different types of this, PLA and PLA plus. PLA plus is generally, they've changed the formula of it so that it's stronger. I've only ever used PLA plus. It has been as strong as I've ever needed it. A quick example of that here is, this is a downspout diverter. Put this right into my downspout and essentially it catches rainwater, diverts it into a rain barrel, and if it's at the proper height, when the rain barrel's full, it backs up in here and then goes down the rest of the actual downspout. This is printed out of PLA plus, and it is very, very hard, and it's been outside for a full year, took it out in the winter, and have no issues with it. And again, that probably cost me $1.50. So if I have to print one again in another 4 or 5 years, it probably wouldn't hurt my feelings to do so. Definitely don't want to if you don't have to. But it's definitely the cheapest and the easiest to print. It prints like butter. That is probably the easiest thing to say. It's the most stress-free print you can use. It's very low temperature to print in compared to some of the other ones. So it makes it very easy. Next up is PETG. I'm not saying those words, but I use the words stronger. Okay, PETG is generally used in a little bit stronger places. I've used it. It can be a bugger to print. It is a bit problematic to print sometimes. It doesn't adhere to the bed very well, so sometimes you're printing something and it just falls off the bed. And again, gravity is going to not be your friend when that happens. It looks the same. I didn't bring up anything different, but I've definitely printed with it. A lot of people print PETG to go outside. I've not, and again, have not had any issues. I think PLA Plus has definitely come a long way, and again, with its pain in the butt to print, it's kind of turned into kind of the thing we don't talk about a whole lot. Next up is something called ABS. This is a type of plastic that venting is required. So people that print this, it's a higher temperature. They actually create enclosures for these, and sometimes they can be just a little tent that sits over top of them. And you generally need to vent that because those fumes, as it heats it up and actually extrudes it out, can be not good. I do know of somebody that says he prints it all the time and it doesn't affect him. He's got a twitch though, so I'm not sure. Not true, but ASA is essentially the next iteration of ABS when it comes to printing. Again, it's venting is required. They do say it's UV resistance, so outdoor use is a lot higher, a lot better chances. Again, there's forums full of people that print PLA and have this in the sun all year long, and they don't have a problem with it. So ABS and ASA is not something I've intending to print. Again, that venting to me is a big deal for me. If this is no longer a hobby thing, that might be something if you're a workplace and this is something you're going to do, it'll turn into something else. And the last one is TPU. TPU is probably one of my favorites. And Brian literally has one in his hand back there. But essentially, TPU looks the same. I assure you it's not. It's a bloody rubber band. That's nothing. Don't worry about it. It's a rubber band. So you're printing rubber. Damn near. The easiest, I've used it for a couple of things. So these are coasters. Again, things I just needed to print. This is PLA, hard plastic. This is TPU. This is very common for phone cases, right? People print their own phone cases all the time. And it's good for if you've got some liquid touching it or anything like that, because it generally is less porous. So liquid would sit in here the whole time. So I've got a tea bag infuser, or not infuser, where I leave a tea bag, and I had it sitting on my desk, and I picked it up once, and had wrecked part of my desk. So I printed it again in TPU. What else have I printed in TPU?
Gumby?
A phone case. Yeah, you're right. Gumby. Yeah, Gumby. I could print a Gumby. You're right. So TPU is finicky to print, but when you kind of got it dialed in, it can print some neat stuff. The problem with this is when you do something like supports. So if you were to print something with those organic supports, because that rubber only works when it's infused on top of each other, you generally have to cut them out, which can be a little bit problematic, whereas plastic can kind of break off of each other at a weak point. Alistair?
Is it possible to have a clause so you can change the material?
Oh, I was waiting for that one. You can, to a point. Some materials don't quite work well with others because, again, if you're printing hard plastic on top of something like TPU, you could have problems with that layer has to be so properly dialed in. It could be problematic to adhere to that. So most common people print PLA on top of PETG because they're pretty close to being the same, but people do have problems with them where they'll print fine, but the structural integrity, that's kind of a weak point. So if something's going to break, it'll break at that spot. So it's generally not something you want to do at this point. It might be something that they continue to tweak in the future. But past that, we should be able to print, right? Heck no. More things to think about. And this is important. I'm not trying to make it like this is a very difficult job. I did mention to you guys that these things are all, I keep them in Ziploc bags. I literally have silica packs inside of them, hydrometer dials, so I can see if my bags were open. And if they were, you generally have to dry this material inside of a dryer. If you keep them bagged, you generally don't have too much of a problem, but I keep all of my stuff bagged so that I don't have to dry them all the time. So outside of that, we need to worry about nozzle sizes and layer height. What? A thin piece of plastic is a thin piece of plastic is a thin piece of plastic. It's not. So we actually have to do two different things when it comes to nozzle sizes and layer height, and that is essentially how big is the hole that this plastic is coming out, and why does that matter? The best way I have thought about it, it was not my idea. Somebody had said, if you have a ketchup bottle and you put a bead of ketchup on a plate and assume that hardens and you put another one on top, you're only going to be able to make that bead of ketchup so big, and then the next one on top of it. And granted, it has a certain amount of squish happening here, etc. But those nozzles allow you to get more precise. So the more precise means you don't get to see as many layer lines. So when you actually come and take a look at some of this stuff, you'll see those individual layers. A smaller nozzle will get you obviously a lot smaller layer lines. Outside of that, and keep in mind, the smaller the nozzle you're going to guess, the more time it takes to print. So I'll show you in the slicer, if we get a chance here, just changing the nozzle can be the difference between, say, a 2-hour print and a 12-hour print. But you'll see that quality difference between those layers of plastic. Does that make sense? Patrick?
Do you find there's a difference in waste between the nozzles? Like a larger one would create more waste?
No, I think the biggest issue I've ran into, 0.4 is probably the most standard nozzle. It's hard to read on that one, but 0.4 is the standard nozzle most of these FDM printers print. 0.25, I think it is. I have one of those. Oh, is it nice when it prints, but my goodness, the time it takes. But I also have a 0.6 and a 0.8, and I printed something on a 0.8 and I went, what, that is ugly. Because you can see the layer lines like crazy. But if you're printing something that you're not gonna see, you just need plastic built on top of plastic, you're gonna save a lot of time. And in this case, the plastic, you're using the same amount of plastic either way. I've not noticed anything other than sight. And if you're not going to use it because it looks like garbage, then it will create more waste because you'll change it and do it again.
And you select your nozzle size back in the slicing program?
In the program, yes, but it's an actual physical part, right? Obviously in the nozzle. So you have to tell it, there are safeguards inside of the printer. So when I actually finish the slice and send it to the printer, it has embedded in there that I'm printing on a 0.2. So if you try to load it up and the printer says, woo, I've got a 0.6 in here, it'll actually error out. And you can hit continue, but it will not work. I don't know why they have the continue button in there.
But you can select the nozzle size in the slicing program.
Yep. I'll actually cut to that here as soon as I'm done here. But yeah, that's important. I love the 0.6 nozzle. In fact, that's what's printing right now. And one of the biggest differences between these printers is the ability to change the nozzle. So this little guy here running a 0.4, this thing is a workhorse of a workhorse. Anything I throw at it, it prints. To change the print head is a process and a half to change. The model beside it is specifically made to actually swap the nozzles. There's 2 side screws on the side that you can use by hand and drop the nozzle right out, slide a new one back in, change the setting in the printer, heat it back up, and you're good to go. And it's actually designed like that. That's one of the major things part of that type of printer. That answer your question? Okay. Next, we have to talk about layer height. Again, you're just putting plastic on top of plastic, but it actually matters how much squish that you're actually pushing into that, for lack of a better phrase. And you'll notice here, you can actually have more squish, but why does it matter? Again, for aesthetics. When you have curves around an item, the more squish, the better. You're not going to see those layer lines. A great example I'm going to cut to as soon as I'm done here, I'll show you how many layers it adds by changing that. So essentially what that means is, when we combine them all, we can actually say the layer height stays the same, but just changing the nozzle is enough to actually change the dimensions of that item. That's a great, this is not something I printed. I promise I didn't print it. But that's just an example of using the exact same layer height and those nozzles just extruding that different size of plastic. The ketchup bottle hole changes, and it changes the way that's printed. Now I'm going to cut away from that quickly and go back to our slicer program, because basic slicer. I'm going to load up this one again. So if we go back to our head item here, actually, I should go use the one that we were talking about earlier. The beautiful one that I made in Tinkercad. So in the one that I created in Tinkercad, there's the mouse. You'll see here, I'm actually going to switch to this other printer here for a second. This is, so you'll see here, up here, 0.4 nozzle and then the quality. I'm not going to try to go crazy faster here or anything like that, but essentially I can actually change this to different millimeters. So you can see here, if I choose the typical 0.15 millimeter quality on a 0.4 nozzle, get that off of there. And if we were to slice that, this would take 2 hours and 17 minutes for a total of that 264 layers. Just want to close that so we can see that. But taking this and just changing the layer to draft mode. So again, that layer height alone takes it down to 1 hour and 9 minutes and only using 133 layers of plastic. Subsequently, if I take that and change the nozzle size and do a 0.8 nozzle, slicing that at 0.3 detail, that's that draft mode it said, the layer height being quite large, we're at 59 minutes, not a huge ton of savings there. But if we crank that, oh, this nozzle won't even let me go any smaller because of the size of it. Let me change that back to 0.6. There we go. So we can go back to 0.15. So a larger nozzle, but more squish, smaller layer lines, and we're up to 2.5 hours. So all of these will add to the quality of your print. And again, I'm not trying to make it difficult. It's just a matter of understanding how plastic is just going on top of plastic. Make sense? Any questions? That answered that one better, Patrick?
Yeah.
Yes.
Would it change like the speed of the nozzle moving?
No, the nozzles move the same speed. I'll get to something very quickly about upgrades, because the need for speed is always, whatever hobby there is, there's something that, to that, but we'll dive into that if time permits. So yeah, there's that. That's kind of it there.
That looks way easier to adjust the stuff that you were doing than the Ender 3 did.
Right, okay, so I'll get to different brands, but that slicer program that I'm using is, I can click in there and you can add your your printer right on it. A slicer is just the program taking and converting it into something it understands. Mine are set, and when I opened it, it says, what kind of printer do you have? I have this one and I have this one. Okay, perfect, we'll put that in your list. But there's nothing stopping you from going in there and choosing your printer, and it's got presets and stuff. That doesn't mean that you shouldn't have to go in there and tweak, and maybe this will work better here than there or something like that. But a lot of
that program looks a lot easier to use.
I have only used this one, so I can't even speak to that, but I could switch to another brand and print it to my printer as well. Gord?
A question online, when do I use hardened nozzles?
Hardened nozzle, fair question. So filament is generally just plastic. Hardened nozzle, well, before I get into that, you can actually buy, the most common one I've seen is wood grain. So you can actually buy a filament that looks, and when it prints, it comes out as wood grain. The problem with that is it's got flecks of wood in it, and that will break these down. These are brass nozzles. So that type of material will break that down and cause issues. So there's people that post pictures online of this nozzle that looks like this after a little bit of work, because you're just going to wear that out. And I'm not entirely familiar with a whole lot of different brands. It's not something that I've done, but I know that you can get, I think you can get like metal inside of them, etc. Brian?
Diamond ones.
Yeah, like
down the States that make diamond nozzles for.
yeah, and that's the hardened nozzles. I'm saying the actual filament. I know there's wood in it, and
Carbon fiber.
yeah, all sorts of different things. I have one here that they use, if you get a chance to look at it, they actually call it Galaxy. It has sparkles in it, but it's not considered anything to worry about that will actually wreck these nozzles. So nozzles are considered consumable. Hate to say that. I've not had to throw one out, but if you use them enough, especially if this is kind of your business, this is considered part of your, like fans or anything like that. Those are considered consumables items. Nozzle height, I showed the kind of creepy dude. Now we move into, it's printed. It's sitting here, post-processing. This is not a whole lot of the world I live in, with the exception of that. If you're doing something with supports, you're gonna have to go and clean those off afterwards. Maybe you'll take it and do some sanding. So there's some people that will actually take, especially if you're painting something, again, not a world I live in, they'll actually sand it down before you paint it. Jeff?
What happens if the power goes out after 10 hours? Does it save in there? Or would you
Some printers do. These ones do, yes. Generally, some people put them on a UPS to try to ride that out. I've had mine. I may or may not have turned the heater on in the room and kicked the breaker out. I mean, the power went out. I don't know what happened. It happened. It was totally my fault. And I went, oh no. And it was maybe 2 hours in on a 4-hour print. So it wasn't a big deal, but I went and flipped the breaker back on and it came back up and it says resume. And I'm like, okay, let's see what happens. I didn't notice a difference, but I do know another time where power had flickered, I swear, for real this time. And it said resume and I said resume and it was kind of printing offset, like it kind of lost where it was. I'm not sure why, but that's been something recent in the firmware of the units that have that failover essentially. If you need it that bad, I guess you're probably going to throw an UPS on it of some sort. But again, extended power outage, I don't know. You're going to take some chances there. Yeah. Yeah, it happens. I've seen it, but it's only happened really twice to me, and it was not a major thing. And of course, after sanding, painting. I'm going to show you a quick picture of. So I had printed an item. I think I showed some of you have maybe seen this before. So I had a friend of mine contact me and says, James, I want you to print a. Guys, help me. A Balrog? Lord of the Rings. Well, there, see? This is what I printed. I'll just, and this is in process. So you can see here, this is kind of an in-process scenario of the organic supports and doesn't look like much else. But if I go through the process, this is what it came out to be. I took pictures of it. I'm like, I don't know what this is, but this is insane. In fact, I wouldn't even let my daughter take it to school to give it to him. He's a teacher because I was afraid she was going to wreck it. This probably took, yeah, Tony?
Where did you get that?
That was on that printables website. I actually went to try to find it yesterday. It's been removed. I feel like it was a copyright infringement, but I don't know that. It's not there. And I didn't take a copy of it after I printed it, so I don't have it. I know. Again, I still don't even know what it is, but the quality of it just blew me away. And this is a 0.4 nozzle. This wasn't even a 0.25 nozzle. It was incredible. The supports on this, again, if we go back to the first picture, I took this at 7:30 p.m. It was kind of a, see what the morning brings. Hopefully it's something that resembles whatever the heck that is. But the supports took me probably 45 minutes to cut off, specifically because the spikes right here, you could see those supports were kind of all the way around. So incredibly delicate, came off quite well, but I wasn't going to be rammy and ruin this. It scared the heck out of me. Now, he actually actually met with him on the weekend. He printed this. He asked me to print this for his brother. And I'll quickly scroll down to, this is what his sister, it would be his sister-in-law. He showed me this just on the weekend. He said, yeah, she painted it. And I went, holy man. So again, not a world I live in, so I can only show pictures of other people's work, but it was incredible. Roughly 20 hours to paint this. I don't know. I mean, if you look into the, yeah, it's crazy.
Isn't there chemicals too for smoothing print lines?
There is, yeah. There are chemicals that kind of break it down, as I understand. I've never had to use any. Most of my stuff, it's a box. It's this. It's things that I'm making for certain things, and I've never had to do that. But I've seen some stuff, and I understand it. Just kind of, it's almost like a paint thinner type of thing, where it kind of acetone. There you go. Yeah, and kind of takes a little bit of the edge off for those lines and allows a smoother coat, especially if you're going to paint it or if you're going to. There you go. Printer's done. That was good timing. Like I planned that. So yeah, I've heard that. I've never had to use that. All right. Yeah, that's the picture that I wanted to show. I did want to go through what other stuff have you printed? Because I think Gord put it best with, it's a 3D printer. What stuff can you make? I put a collection of stuff together. Some of this stuff is James running around the house going, I'm going to print this stuff. So most of this stuff is just a folder of mine. Oh, there's a good one. There's the, I'm not sure if this is going to load. This is a video of the first time I used glow-in-the-dark filament. This is for the potato gun, I swear. So I was blown away. Go charge it up in the sun. Well, yeah, it was really cool. We ended up shooting these off in the middle of the night, and people were out in the field with their hand with a baseball glove catching them. It was awesome. Again, my brother put a few in the dugout, from what I understand. A lot of this stuff. Oh, I printed. I put one of these in, and I didn't like it, so there's a kind of a made that work. How's that? There's the potato gun. So there's again that infill. This is a video, I believe. Actually, my sister-in-law, she wanted to see what the heck it looked like when it was printing that infill. This is that gyroid infill where the jagged seams does the outside line, and then you'll see it actually kind of, the head never moves, right? The base always moves. The head's stationary, it only goes up and down. I had that video for her. I've just kept it. I've shown a few people. This was a project that I actually did for my youngest. This took me a really long time, and I'm quite embarrassed of how long it took me. But essentially, these were hexagon boxes that I printed. A better version of them. Nope, there we go. Hexagon boxes printed in black, and then I printed the white, just white, not clear, lids on them. Wired them into that with those microcontrollers. To make an LED light system, which looked like. So I actually wired this up and plugged it in, turned the lights off, ran upstairs, grabbed my wife and went, this looks incredible. I did not know it was going to turn out this good. This one took me a long time. I probably sat downstairs untouched for about 6 months before I finally did it, and I wished I really would have done it a long time ago.
So when your wife saw that, did she allow you to buy a third print?
I'll let you know. Not a word. And this is just using some automation software that I use, but this is currently stuck on her wall in her room, and she uses it all the time. So I was really blown away by it. That's just a picture, I believe. Yeah, really impressed of how that worked. And this was kind of a happy accident. I should do this, turned into, ooh. And then a friend of mine messaged me on Instagram and said, can you make me one? I said, no. Yeah, other than that, my daughter found this ghost. Looks like a crocheted. That's the word I'm looking for. A crochet. That is not crocheted. That is hard, rock hard plastic. And this is a good example of, you can see that it's completely an open shell inside. You can put your whole hand inside almost. So this was one that the supports were really good because they went right up into the eyes, into the mouth, and you just popped them off. You could see a little bit of remnants there. You could probably just cut that off if you needed to, etc. But of course I made one, and then she says, no, I want more, different sizes. Turned into, can I get some that are glow in the dark? And then I said, this closely resembles a shrine. I think we're gonna call this good here. So that's the end of that one. LED lights. Oh yeah, we have, and this is this kind of stuff that you end up running into around your house. You just like, God, these things are just laying around the counter. I need to clean. These are water pick flossers. And I'm like, that's fine. So I whipped this up in Fusion. It's just a block, couple of stages, put a couple of holes in it, print. Wife says as long as it's white, she's happy because it matches everything else. That is sitting right here. In fact, this was actually a kind of a printer stress test. These are individual strands that a properly calibrated machine it's really hard to do because that strand has to be suspended in thin air. Remember I said, there's no supports in this. This is how it comes out. But more specifically, it has to cool that so that it keeps its structure as it's being made until it reaches the other end.
Is it printed on the side or standing?
It is printed. Oh, the ghost is not part of it. It is printed like this. And so you'll see it's kind of, wow, gravity kind of pulls it apart. And everybody wants to poke it too, I'm told. Is that true? Everybody tries to poke it. So yeah, this was kind of a, see if you can print it. And I printed it and I went, I've only printed one. I'm kind of afraid to do it again. So that was just one that I had, one of the people that I follow printed one, and she says, here, use this. And of course she went and stuck another glow-in-the-dark ghost into it. This was the hand for the robot, for example, and you can see those organic supports kind of helping. There are holes inside of the fingers. The fingers, I believe, are hollow, I believe. And then of course you take the supports off, and that's what it looks like. Of course, I just had to document this. Few of you have probably seen I made a bunch of these at Christmas. So these are 2 layers. That's all they are, 2 layers of plastic, and you throw a tea light into them. So inside, if I break this, Aaron will kill me. But essentially all they are just a single or 2 layers of plastic, and you just put them together, put a tea light in them, and away you go. So I made a bunch of those. Pretty sure one of these is a video. Not that it matters. Nobody needs to see a video. Oh, like that flickering candle one. Anyway, and then I made another one. This was kind of a stress test as well. Some kind of a ball. You throw a tea light in the bottom. Little things like that. These turned into a trinket of, hey, these are cool Christmas things. I didn't even give this away to anybody. I think it's still sitting on our counter. Time lapse. People love time lapse. So I bought a camera. This was like December 29th. This has not been dialed in, but this is a good example of, a time lapse of speed to create another planter. Nothing too spectacular here. I usually come in and turn the light on and off and stuff like that, but you see a lot of these online as well. Oh yes, so this is something new I've been playing with. This is something called Gridfinity. This is a really neat idea that I just got into. This was February. Oh yeah, I just took this picture this morning, but this is something I just recently got into. This is just a chunk of plastic, quite good. And this, somebody had created this system called Gridfinity where you print these bases and then anything you can imagine. This is kind of like a garage, somebody's garage or toolbox's dream, where everything is based on, you can see those grids, everything lines up. So we're talking everything's stackable, everything's, I think, Melanie, you've seen mine in my office, but in my basement, I'm kind of went a little bit all in. Started cleaning out drawers for screws and controller boards and wiring and all sorts of stuff. So this was when I kind of got into and started cleaning up my office a bit. Not quite where I need to be yet, but this is just something I've got into recently. Honeycomb storage walls. This is something I got into a while ago as well, where this is kind of the same version of this, the desk organizer on the wall. And you can print these in pieces, connect them together, attach them to the wall, and then there's parts that actually stick into them. Put your toolbox up on the wall or whatever the case is. So again, my office, it's not something you're going to probably put in your living room or kitchen necessarily, but just again, something that I do. Alistair.
With the Gridfinity, is it close enough that if you were to connect two of the grids with the storage containers, would they stay together? Or
oh yeah. I mean, they're held in by, they're designed for gravity. So for example, this is a toolbox that's got a bunch of stuff, and they're just designed with the tolerances that they sit inside of each other. But no, they're definitely not something I'm going to tip upside down. I mean, they're designed to sit. So again, this is just what I've done stuff. Planters, my God, planters, toothpaste holders, you name it. These things are cool. No, you can't, you laugh, but this is the best thing in the world. Did I take a picture of, I went around the house. Oh, there's one my wife quite likes, made a bottle storage things, cleaned up the cupboards. This is one I did in 0.8. You can darn near see the layer lines. They're pretty ugly, but again, I'm not looking at them and they hold up perfectly fine. I literally was running around the house, like taking pictures of all the stuff. Toothbrush holders. This is cool. Everybody needs one of these. You literally put your toothpaste in there and you will not run out of toothpaste until it is finally out. Closet hooks. I remember one day my wife just says, it would be nice if we should get a hook. I'm like, I know somebody. You just whip one up. These are the type of things that you're just like, once you have one of these. And then, oh yeah, I hated silverware, so I just made a cup with holes in it for drain. And then planters. You can see the planter I just made here. This is just stuff I've got at work, different sizes. That's the one that was in the time lapse. This is a really interesting. The one that I just did here is a specific mode in the slicer called vase mode, however you want to say that. And the idea behind it is normally it does a layer, stops, moves up, does another layer, moves up. I mean, quite fast. You'll never see it, of course. Vase mode, however you want to say it, will actually shortcut the programming so that it continues in it constantly moves. Now it's still moving up, of course, but it doesn't stop, move up, and move around. So you actually don't get seam lines because, of course, as it's moving, there's seams. Cuts down the speed of printing these drastically. So this vase I printed took 2 hours and 3 minutes or something like that to print without being able to have it in continuous circle mode, in vase mode. It would have taken probably closer to, I'd say, almost 4 hours. So it just cuts it down, shortcuts it, and for speed, you won't have any layer lines or anything like that. Oh yeah, and then there's the wonderful world of how many colors do you have? This turns into even my wife, when she's finally caught on board with this, she's like, hey, I want you to do this. Do you have this color? Not yet, I don't. I usually don't say that out loud. I usually say, I will, and grab it later. So I print most stuff in black and white, or white and black and a lot of blue. That's pretty much it on the show and tell side, but I did want to talk about something inside of Fusion 360 that blows people's minds. Well, at least mine anyway. Fusion 365, this was the example. That's actually a Gridfinity box. They actually created a program that just creates boxes and allows you to do whatever you want. Don't save. I don't need to save that. I just need to see this on my screen so that I can be quick about this. So there is actually something called, people create designs. You'll see a couple of them here, these boxes called, they call it a rugged box. Yes, it's nothing too crazy. Let's be completely honest. It's just a box. There's just a couple of actual metal screws in here that are allowing this hinge system to work. But this box somebody created. I did not create it. I printed it. But they'll actually design them, and they call them parametric models. The hell does that mean? A parametric model essentially means that they created this to be changed. You're like, oh man, that sounds like a lot of CAD programming. But they actually created it so that you can actually modify this. So you'll see it quickly here. I can actually change the parameters. That probably came up on my screen. Let me just pull that over. And you can actually say, no, I want this to be so many millimeters by so many millimeters by so many millimeters. And you can change this on a whim. So if I wanted to say that the inner box depth is an 85, I'm just making numbers up, 120, and hit enter. That box, you probably just saw it in the background, changes automatically. I don't know CAD in order to make this change or anything like that. And they do some pretty interesting stuff with this. I can add more latches, one latch. I can make it taller, shorter, whatever the case is. And these parametric models, these people have made, allow you to say, here's the model. Instead of you taking it and mucking with it, we're the ones that had to do all this work. And you can see here in the Fusion, this is all the steps that they've had to create, or at least some of them, I think it went off the screen, to create this box. They actually made some of these variables, these numbers that they put in here. They're like, here, we're going to let you change these, and we're going to make them just a variable that you change that number, we'll adapt to it. Bigger, smaller, whatever the case is. One of the other boxes. So this is an exact, the same model, different size. All I've had to do is take the calipers out, and I use it to carry a travel router that I use. And then I just padded it, and then away I go. And then a lot of people, there's actually, you can see the blue, what do they call it here, the gasket. Yeah. And you can actually print that in the TPU, that rubber, and then make them more safer for weather. I wouldn't say waterproof, not water resistant. You're right. That's the one where you're like, sure. That's the don't blame me if it gets wet story. Yeah. So you'll actually see here, if I can find my mouse again. So there's actually different parts. So there's the seal. So when they design these inside of these programs, you'll actually see that this is the CAD part that's not there. I don't know if I ever will be, but one day maybe. You'll actually create these in separate pieces, and you'll actually you'll have to print these in the base as one item, the latches. I mean, you could put them on the same print bed and print them at the same time, and then the actual seal as well. So you can do however you want, depending on the size of your print bed. You can, when I loaded up that one model, you can load 3 models, arrange them on the bed, and hit print, and it'll print all 3 models at the same time. It's whatever you want to do and what risk you want to take if it goes awry. It doesn't happen, ever. But I just wanted to touch on that because I show people this parametric things and they go, whoa, these exist for free? This guy's, it's on printables. You could just go create these. And that's when I needed to carry this item with us in our suitcase. I took out the calipers, measured it, printed it, tweaked it. And then what I ended up doing is just the way it was, just printed a little base because it was one part was too tall and one part was shorter. So I just went in there and created a base, plopped it in there, and away it goes. So this is the type of thing you really start playing with and go, I could do that, I can do that, and you can do that. And then that's why you have toothpaste holders or squeezers. Yeah.
And 2 printers.
And 2 printers, yes. No, I'm going to go on record on the video and say no.
I can use AI to change.
Yeah, you would. Anyway, so parametric is kind of the one thing that I wanted to talk about. The other topics, I know we're coming on to, it's 8:30 now. One of the things, a couple of things, and feel free to jump in at any point in time, but I kind of wanted to talk about a couple of things. And I've already touched on one being, there's a million different printers out there. I would say probably the 3 top ones that brands that exist right now is Prusa. That's what these ones are. Prusa, followed by Bamboo. Bamboo is up and coming, I would say. I'm not going to pick on them. I'm going to try really hard not to pick on them. Prusa is considered open source. They open source their parts. In fact, if you actually look close enough with the printers, they actually print some of the parts for the printer on a 3D printer. Kind of a chicken and egg thing as far as I'm concerned, but regardless. If you need to, they'll actually publish their parts and be like, if you break a part, maybe you should print these ones before you break it or have somebody else print them. Their software is open source. Bamboo is a fantastic company. They actually make really good printers. Closed source. I believe they are a Chinese company. They are for sure, yeah.
Bamboo and Creality are Chinese.
Yeah, Creality, whatever, yeah. A lot of people have issues with Bamboo because they're kind of ripping everybody off. I'm not going to say that. I just say if the printer works, great. Prusa is known for their support. They have a 24-hour, anything you need, chat, phone, everything. Bamboo does have some support over only by email, and I've heard that. So if somebody please correct me if that's wrong, but most common, there probably is Ender, Creality. Yeah, they're very inexpensive. So that's kind of their claim to fame is you can buy those printers for $150 to $200, $400, depending on what you get. Yeah, like any hobby.
230, I think it was.
230? Yeah. So you can get into it. There's a lot of manual labor into some of those ones. I got into Prusa for one reason, and that is they were kind of designed to print. They're kind of workhorses. I would say Prusa and Bamboo are kind of the ones where you take them out of the box, not a whole lot of fiddling, get printing. And to me, that lowers the barrier of entry, if you ask me. That allows you to get something in your hand and say, I did this, as opposed to, it doesn't print, I need to calibrate it. There's some calibration that I need to do. Not saying there isn't. Really quickly, Brian Wright, vice principal at the comp school, the guy that he had to go buy his own printer because I kind of screwed him over on that deal. He called me on, I guess it was a week ago, and he says, James, I need your help. And I'm like, what's up? And then I got a picture. That's what I got. Yeah, he had a nozzle leak inside of the head. Never actually seen it in person, saw a ton of them on the internet. That is hard plastic. You cannot, as he told me on Saturday, side grinders won't touch it. Anyway, long story short, this whole mechanism had to be removed. Had to be removed and replaced. Took us maybe a half hour, and we were back up and printing. Because the parts, we got them ordered right out of Calgary. They were here. I think he ordered them on, he told me I ordered them on Monday, got here Wednesday, changed it on Saturday, an hour and a half, and he was back printing. So I'm a big fan of that. For Prusa, again, not picking on anything because you can get parts and all sorts of stuff for enders and any I'm forgetting all the names, but there's definitely reasons to go with a brander name like Bamboo or a little bit higher cost ones, I guess is what I'm saying. Yes.
Do you have any like because some of them use ball screws and then other ones use belts? Is there do you find any problems with belt-driven ones or?
Do I? No. However, they do exist. A lot of people, shouldn't say a lot of people have issues where the belts will jump if they're not tightened properly. The belts have cogs in them to go into the screws. If they jump, you'll print something and it's kind of like everything's prints and then everything shifts over a little bit. Well, the print's ruined. And what's happening? So they make tools to calibrate your print or your belt and make sure the tensions, there's actually all the screws you see on the front of the printers are designed to just tweak them and it'll tighten the belts. And there's actually an app that they create that says if you twang them, it'll make this sound like a B flat, or I don't know what the actual musical note is that it makes. So there's that. So I've not had any issues with it myself, but I think it's like anything. If you do the proper maintenance on these printers, which after X number of hours, you're supposed to do something. This printer here is about 6 months old. I'm not proud of this, but here goes. Print time on this has been 61 days and 2 hours, and filament is 3.4 kilometers of filament. And that's just my second printer. And I tried to pull it up on my other one, but I did a firmware upgrade on it and it wiped it. So it would be more. That's all I'm going to say.
How often do you find you have to level a bit much with the person? No, I don't know.
If you don't touch it, never. The MK4, the other printer, the claim to fame is it's got a load sensor in it. So what Kelly's talking about is that head has to be an exact measurement off of that bed because you need the perfect amount of squish for the layer lines. So you have to dial that in. It's quite easy to do. It is on mine, is what I'm saying. But this printer, I have to dial that in. So if I change it to a PETG or a TPU, you actually have to redial it in and such like that. The MK4 is designed so there's a load cell. So essentially it's a pressure sensor. If I change to a different type of filament, I tell it in the system that I'm changing to TPU, and it says, okay, cool. We know we have to do it at this temperature versus this temperature, and away it goes. As soon as it touches that bed, the sensor in it knows, oh, that's where we're at, and you get a perfect first layer every time. I've never had to touch that printer since the day I took it out of the box, and it's claim to fame though.
And I might have to play with it every once in a while.
Yeah, and I have to change, like when I transported mine here, I had to retweak it, which I just load up a little thing and you sit there and you dial it in and it moves it and until you get the perfect line or layer, and I'm good to go again. Again, there is pros and cons to these little bit more brand name printers. Bamboo and Prusa are designed to be workhorse, get printing, not too terribly bad. And I think some of the new enders are definitely getting better with that. The software and stuff like that is they realize they just want to get people printing because people that aren't printing are just getting mad. So a buddy of mine, Jeff, the guy we blame everything on Jeff, he's had this printer for about 2 years and he actually set it aside. He says, I can't get this thing to work. So then I bought one and I'm like, this thing's great. He's just like, well, how'd you do this? I'm like, well, read the manual and then it says it does that. I'm not going to say I figured it out myself, and then he starts printing with it and he's printing fast and furious now. And he's actually looking at buying a bigger one too. So it's probably going to be my fault. But anyway.
His wife will blame that on you.
Yeah, that's kind of how it works, doesn't it? The only other thing I wanted to touch on really quickly is, and I'm kind of surprised nobody's brought it up, is color changing. They make Bamboo is probably more known for this.
That one over there said it earlier,
What's that?
changing filaments and color filaments.
Oh, did I miss that? I'm sorry. Alistair said that maybe? Okay. So one of the things that people want to do is, okay, you can print blacks, you know, that flower vase is black. That's great. That's kind of black and boring. So sure, you can mix it up with different colors and stuff like that. But we can actually take, and I have no idea what this thing is. I found it yesterday. I'm not going to lie to you guys. This is Doraemon. I don't know what it is. But what happens is you can actually do filament changes to make this a different color. Let me just slice this to make it look like something here. Give me a second. And the idea behind it is, I was going to mention Bamboo is kind of ahead of Prusa quite a bit in this case, but I've been told by my wife I'm allowed to order one. I swear that. They actually make a unit that can change this. So what you're seeing here is a item. If I actually get rid of the supports, it might be easier to see. There we go. Okay, but if you look at that, if we pull down the layers, you can see in this layer, that layer, that might not be a great example, but if you actually look at this, one layer's got 3 different colors on it. So how does that work when you can only put one layer on at a time? Bamboo has got a unit that does this already. I'm just going to go quickly to what I'm going to buy. But essentially, they make something called a multi-material upgrade kit. And this is essentially what is sitting on top of, I can just, we'll add it on. And it facilitates the transfer of, I'm not trying to show you the price, I'm trying to show you the picture, but essentially the idea is that the unit has, too fast, a unit on top that feeds 5 different colors in, and then the actual software takes care of the loading and unloading. And you'll see, if we go back to the slicer program, you'll actually see when we turn on the supports, might have screwed that up.
So do they have different nozzles then? Like when you feed it,
Nope.
it's the same nozzle?
Same nozzle. It has to be the same nozzle because you can't, you'd have to actually stop, cool it down. I don't know of a way to do that. But in this case, you see here, this is what they call a wipe tower. If we want to talk about waste, this is where it comes in. Because after it changes that color, it has to purge a little bit of filament out so that it's not black going to red, it's actually red. So it's incredibly wasteful in the sense that it goes off to the sides, purges it, and it changes color. And when you're doing a layer like this, one layer, you're doing 4 changes, 4 color changes. So at the end of the day, we're looking at in this, however many layers this is on a print, thousands of actual color changes. And you don't want to be sitting there changing it manually. And I've done 2 or 3 little small trinkets where I've told the software stop and change colors, which all it does is put that pause in to say, change the filament, unloads it, and what way it goes. It was brutal at 2. I've changed it from one color to the other, and it was brutal. So if you have to do this thousands of times, you need to automate this. So just, again, that's not even something that I'm doing at the moment. It's something that I'm looking at in the future. And even then, I'm not sure it's something that I need. So I haven't ordered it, but my wife told me at the end of the year I could order it, and I got a recording of it. No, I didn't.
What are you seeing for practical applications kind of in the future in this world of 3D printing?
Cool. It's like you've seen my slides.
Yeah, like you prepped me.
I didn't. Who are you again? This is probably the biggest thing that I see coming. This is printable circuit boards, which exist now as it stands. There's a couple different ways of doing it. I do not know for sure this picture was actually printed on a 3D printer, but I have looked at a couple of add-on pieces that essentially you mount onto the printer. It doesn't use the actual print head. However, there are some filament that have metal, like what's the word I'm looking for? Capacitive resources, so it can carry electricity. Conductive, I knew it started with a C, thank you. So the idea behind it is you load that into the printer and if it's dialed in right, because if you get that wrong, boy, you're gonna blow something up, right? But you can then start printing your own circuit boards because essentially those paths are carrying the electricity, the data, whatever the case is. That's probably the biggest thing that I see coming.
The old guys in the tractor world have found it too. You used to cast a part, you had to have a wooden part to pack in the sand, you take it out, put the metal in. And you had to ship that pattern, might be the size of your podium, to someplace to cast it at the foundry. Now they can draw the part, email it to the place, not pay shipping, then they would print it out of the PLA.
Yep.
And use it as a pattern. Now they've got rid of all that and they're just printing the sand. Put down a layer of sand, put down binder where it's supposed to be, dump out the free sand afterwards.
Keep
Then we need to have
rinse and repeat, hey?
There's also one that like takes an aluminum powder and then takes a high powered laser and it just prints a metal piece.
Yeah, and then you dip it in.
That one gets baked.
Yeah, that
That one gets baked. So there's another one where it's a layer of something. You have to dip it in something that eats away the negative. I was looking at this about a week ago going, I could make circuit boards, right? And then I was looking into it a little bit further and went, might not be there yet, but I see this. One of the other applications that I found was really interesting. At the end of the last year, I saw they would take 3D scans in the medical world. Somebody helped me with 3D and essentially be able to do, is it MRI? Is that the right word? Where you get an MRI and you can actually print it in layers, and then actually, from what I understood, surgeons and stuff would look at it and go, this is actual real life size. This is what it is. What do we have to think about getting in, doing whatever they do? I'm not the best at this, but essentially, instead of looking at a picture going, I think we do this, they can hold it in their hand, put it on the desk, analyze it, Lego it up. I mean, for lack of a better word, things like that.
Heart surgery. They took a 3D ultrasound of his heart.
Yeah.
And analyzed a valve that the muscle
There you go.
damaged.
Yeah.
They went in through his leg and fixed the muscle on the valve.
Knowing exactly what they were getting into. That's exactly what I read in the fall. It was just like how 3D printers are in hospitals because they're able to just take it and go, well, what if we could see it instead of we think this is it until we get in there.
How big is it when we
Exactly.
actually get there?
Yeah. So that's as live data as it gets. So good.
The first ever 3D printed trachea is actually, they've completely finished it now. They're going to studies where they can replace people's trachea with a 3D printed.
I remember seeing that like a year ago.
Yeah, so they've moved past it and now they're doing 3D printed pancreases now too.
That's crazy.
Somebody said we're not that far off from beam me up, Scotty.
Yeah. So I mean, this is.
You got the watch that'll do everything but tell you time.
There you go. So yeah, I kind of see some applications with, like I said, in my world, it can be in I've got one of these in the basement. So you walk around the house and you're like that, and then you start going, well, what about this? And then somebody goes, well, I've got a prototype for something, and you can right now prototype something in CAD, ship it off and get it, receive it back, cast it in something a week later. And now it's a matter of hit print. Nope, too small. Try it again. Nope, try that again in your own house, right? And I see that kind of unraveling. And the more I've shown people 3D printing, they go, well, what about this? Oh, wait a minute, what about this? And that's where I get excited about it, because I look at these parametric designs and stuff like that, and people go look at that and go, oh man, I could get into this and really get into this.
Another thing is larger scale, like they've been playing with cement. And
yes, the 3D printed houses. That's right. I don't know where that one lies. I mean, it looks pretty slow, but I think it's something to watch to see how they could develop that. But yeah, I mean, that's been making the rounds for the last couple of years.
I mean, you print a whole house and it takes 3 days.
Well, you're right.
How long would it take to build that house if you didn't print it in 3 days?
Yeah. I think it's been a matter of generally you're printing those in locations that don't necessarily need insulation or.
Oh yeah, no, obviously.
Yeah.
Yes.
So.
Yeah.
Yeah, I'm not printing my house anytime soon, but that's a fair point. And it's one of those things that make your head go, oh,
Yeah.
it's this tiny today.
Yeah.
Where could it go?
I got a friend who printed the Parliament building in Edmonton. Of course, he was a cartographer, is that the word for it? They drew maps or something. He drew this whole thing with all the gargoyles, everything all on it, printed the thing.
Wow.
Yeah, and I mean, you saw that Bullrock. Sorry, you know, there's a huge people. I mean, you go into these websites that give away the models and make their own models. I would say it's at over 50% figurines and painting, and that's great. It's just not something I've gotten into. So I realize we're getting way late on time here, but I'm not forcing you out. It's just that's all I had today. I just wanted to make sure we kept the dialogue going if you had any questions.